All right, we are looking at lesson 4 today, so that's going to be item number 9. So yesterday was 13 and 14, and today is going to be 15 and 16. So go ahead and add that to your table of content. Yes, thank you. All right, go over to 15. We're on Unit 1, Lesson 4. Scaled relationships. All right, so we're going to start off with a foldable first, which you're not going to really cut anything out. We're just going to fold this one and put it on 15, but there's no notes to put underneath it. So you just slide your notebook to the side for now. And we're going to look at, first we're going to look at enlarging a figure. If a figure is enlarged, is that getting smaller or bigger? Bigger. Okay, so let's look at this example. I have a rectangle that's going from 3 and 5 to 9 and 15. So if a scale factor is blank than 1, enlarges a figure. So the scale factor has to be what than 1? Mario? Say that again. Over 1. So it's got to be greater than 1. Because if it's 1, it stays the same. So if it's getting larger, the scale factor has to be a bigger number than 1. So what is the scale factor? If we're going from 3 to 9, 3 times what is 9? Call it out.
3.
Okay, does that match? 5 times 3 equals 15?
Yes.
Yes, our scale factor is 3. So scale factor, the number used to blank the lengths of a figure or object. What do we do with the number to each of the sides?
Multiply.
Multiply. So we multiply them to what or what it to a similar figure. So when we multiply it by a number, what's going to happen to the figure, the new copy?
It's going to get bigger by whatever number you
So the object, so we multiply it to enlarge or what? Shrink, yep. Decrease is still a right answer. All right, so let's look at shrinking a figure. If a scale factor is blank than 1, it shrinks the figure.
So you have to divide it.
Nope, we're not dividing. If it's less than 1, and Quentin, I'll tell you why in a minute. Scale factor is all about multiplying, okay? Now, what we're gonna do is we're going to look at how did they get from this to this? How did they get from 9 to 3? You guys say you divided by 3, right? But we can't divide, we multiply. So what I do is I divided by 3, right? That means I'm gonna flip that upside down to find the reciprocal. If I can spell that correctly. I'm writing too fast. So the reciprocal of 3, that means flip upside down. So if I have 3, how do I write that as a fraction?
3/1.
I put it over 1, right? So if I flip that upside down, what does it equal? 1/3. So that means the scale factor equals 1/3. That means I am multiplying by 1/3 because I'm not dividing by 3. That's not how we say it, where you're multiplying by 1/3. So when you flip it, you do the opposite, the inverse operation. So I don't say I'm dividing by 3, I'm multiplying by 1/3, but they are the same thing. Does that make sense? Okay, so again, how do I make a whole number look like a fraction? Put it over 1, and then you flip it, and then that's your new scale factor. So you multiply by that new flipped fraction, okay? Any questions on this? Does that kind of make it a little easier to look at, to understand how the flipping thing works? All right, go ahead and fold that and put it on page 15. Yep, just fold it in half. Just regular. And then just tape that down. Thank you, Lizzie. And you can glue it all the way down if you want, or I'm just taping one side and then opening it, taping the other so that it just opens like a book. And then once you have that, tape your summary over it. How many read over their summary last night? Every night you're supposed to be looking at these notebooks. It's great that we're making them, but they're pointless unless you're using them when you leave me. Does that make sense? If you're not using them to look at home and to study, these are not even worth making. No, the summary always flips. So the summary is flipping over the foldable. You're going to get a practice, you're going to get the lesson paper and the pull down. We're going to do the pull down first, okay? It gave you 2 pictures and they want to know, is it a scaled copy or not? Yes or no? And then it says, explain your reasoning. So you're telling me, is it a copy, yes or no, and why? How do you know it is or how do you know it's not? Okay? This should be a very simple one. So pull down first, and then we're gonna go over start the lesson paper. And then we'll probably end up having to finish lesson 4 on Monday because of testing this morning. And lesson 4 is double-sided. So just make sure when you fold it, it says 4.1 on the front. So this is the side you want first. All right. So again, cool down first and then put that in the box, and then we're gonna start the lesson in about 2-3 minutes. Cool down goes in the box when you're done. Make sure your name is on it. No, your cool down is your pink paper. Most of y'all's lesson paper is yellow. Mine's pink, but it doesn't matter. But you're doing your cool down first, which is the hot pink. And then in the blue box when you're done. So you're just telling me, is it a scale factor or scale copy, yes or no, and why? Why did you say yes or no? You finished your cool down? Clinton.
Is it fine if I, go see
Yeah, that's fine. Mm-hmm. Quickly. You guys have got to remember everything on Monday because there's no going back to lockers next week for tape, for library books, nothing. All right, how many still have a cool down? All right, about 1 more minute. Those that are done, I want you to look over the first question. Up at the very top where it says, what operation do you think? Just put a line through that. That was from yesterday, but it printed on today's. Not really sure why, but we already answered that one. I want you to read over, looking at those 3 polygons, and start number 1 and 2. On 16. Angles, 3 points, and a segment is 2. Okay, if you're done with your cool down, you should be looking over number 1 and answering 1 and 2. Make sure your name's on it. Okay, are all cool downs turned in? Perfect. All right, let's go ahead and look at number 1. Yours is on, I think, yellow paper. Mine was, I just grabbed whatever I had to copy. All right, number 1, name 2 pairs of corresponding angles. What can you say about the sizes of these angles? Okay, remember, how many points are on an angle? 3. You didn't remember that, you write it down. 3. So, name 2 pairs. Well, let's say I chose angle H, G, and F. What is something that could correspond with it? What does correspond mean? Everybody.
Same point.
Same spot. Same spot on the new picture. Okay, Paitlin, or who was that? Carolina. What was one that could correspond with HGF? So I could have put DCB or LKJ. And it says, what can we say about the sizes of these angles? Well, what about DCB? The angle is
Smaller.
okay. So DCB, smaller angle. And LKJ is what?
Smaller sides.
So LKJ, smallest angle. Okay, 2, check your prediction by measuring at least 1 pair of corresponding angles using a protractor. Record your measurements to the nearest tenth. All right, so just so we're looking at this, look how far apart D and F are. How many units? 1, 2, 3, 4 units, right? How many units from H to F? 1, 2, 3, 4, 5, 6. And how many units from L and J? 2. All right, so if this was my original, what happens to the angle here? It went from 6 to 4.
Times it by 1.5. No, 0.5.
Times it by 0.5 and it goes down. Okay, how did they get from 6 to 2?
They divide. Oh,
Think of it.
They multiplied it by
Don't move yet. Listen. Flip it the other way to help your brain. How did they get from 2 to 6? Multiplied by 3. So if we're going backwards, multiply it by. Okay, let's pause there just because some of you are not sure about that one, and we will pick back up on Monday.